so soil fertility updates. And so the main thing I'm going to be stressing today will be what's behind them. I mean, there's no new fertilizer recommendations, changes in sunflowers in the last couple of years. The soil fertility updates that we had several years ago were sponsored or funded by the National Sunflower Association over a 2-year period, and I greatly appreciate that. So here we go. So we overhauled the recommendations back in 2016. So we had nitrogen and phosphate rates over a number of years and intensively in 15 and 16, thanks to the sunflower grant. We had 27 different farmer sites from Beach, which is in very western North Dakota, to Cummings, which is in very eastern North Dakota and up near the Canadian border and down toward the South Dakota border. So we had, the way it was set up, we had 6 different N rates. We used ammonium nitrate and agrotane plus urea to avoid any volatilization. We had decent rainfall, not too much. It wasn't a drought in any year. The first year we had 4 different P rates, 30-pound increments from 0 to 90, and then there wasn't anything going on with phosphate. And so to limit the amount of physical exertion of me and my helpers, we went down to 2 P rates in 2015, used triple superphosphate so it wouldn't confound the nitrogen. So this is a response that we had, very shallow, you can see. So the old recommendations, of course, were yield-based, which are pretty awful. And you notice that even at really low available nitrogen, that we still had some fairly high yields, which means that there's a lot of the nitrogen, depending on where you are in the state and which year and which plot and whatever, that really is supplied by the soil. So we base our nitrogen calculator on relative yield, and they give you kind of an idea of why that came about. This is all the data we generated between 2014 and 2015, and it's the relationship between yield and total available N, which is the N rate we applied, the soil test N to 2 feet, any previous crop credits, which I'm not sure there were that many in our studies because nobody really plants sunflowers after a legume because of the white mold problem. The R squared down to the bottom of the graph of 0.02. If you had a R squared is 0, that means there's absolutely no relationship between yield and rate. And so it's really horrible. So I look at that cloud of data and think every one of those sites that we had the study on had a really strong relationship between yield and N rate. Then you put it on the same graph and it looks like there's no relationship at all. And so how do we look at this a little bit better? So to kind of simplify things, this is what we were looking at before in a very simplified manner. So you have your points of the available N and the yield, and you can force a curve through it. But really what you're looking at is this. You're looking at almost parallel yield response curves from low yielding sites in the bottom to high yielding sites on the top. And that's what we were looking at. And that's why it looked pretty horrible. So what we did was standardize our data. I think in some publications I call it normalized, but really if you're a mathematician, which I was scolded on by Dave Clay and his sister is a mathematician at a conference. And anyway, standardization is a better term for it. So let's say that we have a sunflower site, and we did with high yields of 4,000 pounds. We divided all of the data in that site by 4,000, so we get values between 0 and 1. And then maybe we had a sunflower site in southwestern North Dakota that had a high yield of 1,800. So we divide everything in that study by 1,800 to get values between 0 and 1, and so on. And so everything's on the same scale. So how did this work? I just pulled this at random. It's a wheat one, but the sunflower looks pretty similar. So these are western North Dakota conventional till wheat sites. Both of those graphs are. The one on the upper left is just the raw data, and the R squared is 0.16, which is okay, but not too exciting. But then when we standardize the data and put it all on relative yield instead of actual yield, the R squared more than triples. And this happened every time. Every time that we standardized data, we had way higher relationship. And so that's what our nitrogen calculator is based on. This is the yield again. You notice also that right at the top of the peak, there's kind of a shoulder where if you go to the left or right of it a little bit, really not a whole lot happens. And so that's why the fuzziness of some of our resources. When we normalize the sunflower data as we did in this one, the R squared goes way up. Here it was what? Yeah. So anyway, we're constructed on relative yield, and then we have the value of the sunflowers. And then I also included the decrease in profit that we get from too low a oil, because as N rate increases, oil decreases. And also, as many of you know, as your N rate increases, also your susceptibility to lodging, which is almost every year problem in some parts of the state, that increases also, and that decreases yield potential too. So we have the return to N model that was developed by my colleagues in Iowa State and Illinois. Both of them are retired now. And so what we have is a series of curves within the tables that we have in our recommendation circulars. And so we have three different sunflower prices. 15-cent sunflowers is on the bottom, and then the 24-cent sunflowers is on the top. And then each of those lines within that come off that node over on the left-hand side, that's nitrogen cost at 20 cents a pound on the bottom. That's the bottom curve in each one of those. And then 60 cents a pound on the top end of it. And the number that we have in our table is the peak of that curve, wherever it is. So you're thinking, well, how in the world is this possible? Why are we have the same N rate within a region in a high yielding environment and a low yielding environment, and yield goal doesn't enter the equation at all? And that's because the yield goal equations, as I showed before, really don't recognize that soil has any participant. It's not a participant in this at all, but it's a major participant. So in a low yielding environment, it's usually due to dry weather. And during dry weather, the microbes in the soil that release nitrogen from mineralization of residues and organic matter, they're dormant pretty much. And then also the free-living asymbiotic nitrogen bacteria, which are present in all of our soils. You don't really have to buy them. Though that activity is very low too. I've done testing on that and had papers on it. So the N use efficiency is very low. The N supplied by the soil is very low. The N that moves to the roots is almost non-existent, and so it takes far more nitrogen per pound of sunflowers to make a yield in a low yielding environment than a normal environment. And then a high yielding environment is where you have nice moisture all year, not too much, not too dry. And so the microbes are working overtime and supplying huge amounts of nitrogen, and the roots are able to explore a lot of the volume of soil underneath them, and then water moves to the roots with nitrate. And so the supply of nitrogen to the plant is way, way high. So what that means is that in a high yielding environment, it takes far, far less nitrogen to make a pound of sunflowers than it does in a normal year. And so those are the bookends, and everything else is in the middle. So the same rate of nitrogen that's needed in maybe a low yielding environment is about the same rate of nitrogen that you need for high yield / profit in a high yielding environment. So yield goal is not important. So don't even think about it like that. Just follow the calculator and go from there. So as I mentioned before, the lodging of sunflowers really increases with nitrogen rate. And here we have a location in Botno that shows exactly that. At very low nitrogen rates, the amount of sunflower lodging after a big storm is fairly low. And as the nitrogen rate goes higher and higher, then the lodging goes higher and higher. And then oil decreases also. It's not just this one site. We showed it on every site. And so oil content decreases. And so the nitrogen rate that we have is modified due to lodging and also due to the oil content. It's an economic analysis and as well as an agronomic analysis. In addition, as far as I know, this is the first study that we had thanks to Roger Ashley. He's been retired now for quite a few years. He's a plant pathologist out at Dickinson, and he helped me with the site. And then Sam Markel helped me with the ratings of it. But sunflower rust rating increased as the nitrogen rate increased. And just anecdotally, I suppose maybe I shouldn't even say that, but I'm just going to go ahead and say that. But it seemed to me that the white mold increased as the N rate increased also, and I think that might be intuitive because your leaves are bigger, the plants are more lush, and so it prevents air movement. So I hope at some time that somebody actually does some work with that, but that was just an observation I had, but it's not in print anywhere. So there you are. So we have these tables, and if you don't like computers, these are printed in the in the Sunflower Circular, and so you can refer to those. But I would really suggest that you go to the nitrogen calculators. You go to my webpage, NDSU, Dave Franzen, NDSU, and then on the right-hand side, you can see the nitrogen calculators for corn, sunflower, spring wheat, durum, and two-row malting barley to 2023. So that's where you look. Let's go through a couple examples here. Let's say you put in the sunflower price. Here I put 21 cents. Nitrogen cost, I put in 50 cents. 3% organic matter. You put in your 2-foot nitrate test. Here I wrote in 40 pounds. I put in no nitrogen supplying crop, Western region, conventional till, oil seed, push to calculate. The recommendation is 79 plus or minus 20 pounds. Remember the shoulder I explained to you? So I'm giving you credit for common sense. So I hope you appreciate that. And then let's look at another one. So the same parameters over on the left-hand side, Western region again, but instead of conventional till, long-term no-till on oil seeds. And let's see what it looks like. 29 pounds. It's 50. Recommendation is about 50 pounds less, plus or minus 20 pounds of N. So you're thinking, if you haven't heard the spiel before, here it is. So I'm pretty sure I have time for this. So I started on June 13th, 1994, and I'm going to retire in this year on August 2nd. So I've got five months and 5 days left, but who's counting? So in that winter, I was invited to speak at the Manitoba, North Dakota Zero Till Conference, and some of you remember that when it was quite the big deal. So it was at Minot, and so I went and I talked, and I remember it because the next morning I woke up, and it was a very different winter that year than this year. It was 45 below, coldest I've ever been in my life, there before or since. So I remember that, and then I also remember it because the night before, the committee members asked me up to an upper floor in the hotel in Minot for a beverage, and so I got to meet and visit with a lot of the original no-tillers in the region. There are people there from South Dakota, from North Dakota, in the Canadian provinces, eastern Montana. So it was great. So the North Dakota people told me that they were happy to see me, but also that they didn't follow NDSU recommendations for nitrogen anymore. And I asked them why, and they said, well, after they've been in no-till for several years, they found that they could start shaving their nitrogen rates back, and they'd shaved them off so much that it didn't resemble our recommendations anymore, so they just ignored them. And so I said, okay, what do I know? I'm from Illinois. But I remembered it, and in 2010, when I'd gathered, gosh, I don't know, well over 100 site years of N-rate data on spring wheat and durum from all across the state, I remembered the conversation, and so I split the data into long-term no-till, 6 years or more continuous no-till, and then conventional till, and they were right. It took 50 pounds of N less to make this at least the same yield and at least the same protein as a conventional till field. And then when I went to corn, I deliberately put in long-term no-till sites and conventional, and it was the same. And then when I went to sunflowers, I did the same thing, no-till and conventional on the same data set, split it, and it was the same. And most recently in two-row malting barley. And so it's a thing. So part of it's because of the uptake, I think, of ammonium nitrogen by the microbes. There are far more microbes active in the soil under long-term no-till than there are conventional. And then the other part of it is that we found out a few years ago was that there's a lot more natural asymbiotic nitrogen fixing probably bacteria under long-term no-till than there is in conventional. So I think that's where the no-till credit comes from. But it's a thing, and it's in our publications. So that's nitrogen. So let's go to phosphate. So before the studies that we did, sponsored by the National Sunflower Association, there were phosphorus recommendations in our publications, but that all went away because regardless, look at the P tests over on the left-hand side. We have some as low as 2 ppm and no response at all to phosphate in all of those. And there were no economic responses to phosphate at any site in any year. So we threw it out. I think the relationship with mycorrhiza and sunflowers is just so darn strong that you just don't need supplements. If you want to put some on, fine. I wouldn't put any with the seed, but if you want to put some on, fine. Or if you want to supplement your wheat or your corn or something like that the next year or two, so your soil test doesn't dip. But sunflowers don't pull out that much P anyway, but it's not zero, of course. And then potassium, our recommendations are, I have not seen a potassium deficiency in the state. I'm sure that if you got it low enough and your yields are high enough that you would, but I haven't seen it yet. I'm sure it's coming. Soil test is less than 150 part per million, and apply 100 pounds of 0060. And you need that amount because of the distribution of the granules across the soil. Probably don't need that much, but that's what you need for every plant to get it. I haven't seen a sulfur deficiency in North Dakota ever. I don't think I'd worry too much about it. And the other thing is that sunflowers really don't make their yield decisions until later on in the season. So if you have a crop consultant and they see some yellowing in the top part of the plant up in some sandy hillside after a lot of water, you can supplement put some ammonium sulfate, just granules over the top, or dribble some ammonium thiosulfate in between the rows, and you get a rain afterward a little bit, and you're good to go. And micronutrients, I haven't seen any micronutrient problems. We tested zinc, we've tested boron. I just haven't seen it. So don't worry about it. Just don't worry about it. So we have a extension circular, have the online nitrogen calculator. I didn't delete that. So anyway, we're having trouble with our apps. Microsoft has like 3,000 people working on their apps, and I have a partial person. It seems like about every 6 months or so, they change their platforms for apps. And so we pretty much pulled our apps for the iPhone and the Android. So if you want to use the nitrogen calculator, I'd strongly recommend that you use the one on the web and not the app. So lots of help, and that's my story, and I'm sticking to it. And I'll see if there's some questions.